Welcome to the Post-Tension Parking Structures webinar series, proudly presented by the Post-Tensioning Institute. This series is dedicated to showcasing the advantages and benefits of post-tension parking structures. This four-part series, moderated by PTI's Executive Vice President Tim Crystal, brings together a panel of industry leaders, including Asit Boxy, Michael Pedraza, Tom Pfeiffer, and David Wolkin. Throughout this series, we will deliver practical insights and technical knowledge to empower industry professionals in choosing post-tension concrete as the preferred option for parking structures. Covered topics include functional advantages and benefits, cost-effective design and construction features, sustainability and resilience advantages, and long-term durability case studies. By joining us, you gain access to thought leadership and a comprehensive understanding of how post-tensioning can enhance parking structure design and performance. Let's join in on the conversation.
All right, so welcome everybody to our next webinar series. This webinar series is going to be covering specifically post-tension parking structures. We're going to be talking about the various advantages from all different aspects regarding post-tension parking structures. We're going to have 4 episodes in this series, and we're going to cover various different important topics for the PT parking structure industry. We're going to cover things like functionality, cost-effective design and construction. We're going to also talk about sustainability and resilience, and then we'll have some case studies on long-term durability. So we're going to talk today about all the key things that differentiate a post-tension parking structure from other alternatives, and kind of delve into those details in a panel discussion. So with our 4 panelists here, they'll join in this conversation, just sharing their experiences, thoughts, and expertise on these various topics. And really our point again is to promote and educate you on the major advantages that cast-in-place PT garages have, things that may be somewhat obvious to you and other things that may be less obvious, but then when you start thinking about them, you realize how amazing that is, that they are brought to the table by PT, parking structure design and construction, and how they create a major advantage from a functional standpoint. So I think we'll kick things off here to the panel and start talking with that very first topic, which is the whole idea of parking functionality. Any parking structure you're starting with for any type of owner and any type of site condition is going to start off with its functional design and trying to achieve the owner-developer goals for that design of the garage, starting off with a geometry standpoint on how it's going to be laid out, how it's going to be set up vertically, the ramping, and everything like that. So maybe I'll just kick off that piece of our discussion about the major advantages that PT garages have when it comes to functional design.
Hey. I just kind of wanted to talk about functional design and parking in general. Parking is kind of a necessary evil. People talk about it that way. It's something that everybody uses, but nobody wants to pay for. I don't want to pay for parking. Owners don't want to pay for parking. A lot of times a developer, they want to develop an entertainment venue or retail or residential, and parking is something they need to meet the requirements of the code. And so it's kind of seen almost like a tax right off the front. You gotta pay for something that you don't necessarily get a lot of advantage out of. And if you don't have the acreage to build a parking lot, you're typically going vertical. So that typically requires a parking structure, right? And so owners come to us and they say, well, I have a parking problem that we need to solve. We have a little bit of money for something that we don't really want to pay for. It's often an asset that doesn't generate a lot of revenue. It's often out in the environment. Parking structures are different than a building structure, is that it's typically always exposed to snow and sunshine and de-icing chemicals and all kinds of things. So it's kind of an aging asset that just sits there that needs to be maintained, and maybe or maybe not they'll have enough money to cover the cost of that. So that said, we all have experiences with parking, right? Whether you're parking downtown or you're parking in a structure, you're wherever you go. And nobody really thinks about good experience in the parking structure. They always think about the bad experience, right? I went to this concert and I went in the garage and it was dark and dingy and I couldn't figure where to go. And Then it took me an hour to get out, and it takes one of those experiences to just say, I'd rather park 6 blocks away next time and walk rather than go park at that garage again. So when we have owners or people come to us and say, we've got a problem, how do we fix it? The first thing we do as designers is we're looking at, from a parking standpoint, we want to give them the best function that we can within the parameters and constraints of the project. And the biggest ones that we usually see is dollars, and space count. And then as a third, maybe the site, we may be constrained by the area. So as designers, we try to be agnostic about the system, right? Sometimes that project is dictated to us. It shall be this type of construction, post-tension, precast, steel. Sometimes we can't get around that, but we do the best we can within the constraints of that project. And in our market, and I'm in the Midwest, PT generally wins. And there's a host of reasons for that. And a lot of that stems from being able to provide good functional design. And, form follows function. Louis Sullivan said it, a famous architect in the 1800s said, form follows function, and it does. In parking structures, the function is so integral to the structure itself that you really can't divorce the two. So we try to start with good function, and that means getting people to their destination intuitively and efficiently. So that means we need to be able to get people in and out of the garage in a reasonable amount of time. We need to get them to and from that entrance to their space with ease, and then to and from their space to their destination, which means we need visibility. It's got to be navigable, and they need to be able to do that with relative safety. And with some systems, you're limited in the flexibility of what you can do there. And we're finding with post-tensioning, that gives us the flexibility to create a form that provides the function that we need. And so to do that, the name of the game is we're trying to maximize efficiency, which is basically trying to drive down the total square footage of what we need to build per stall count, because we have to meet that stall count. So that's one of the things that drives it. Another is the ramping system. You got to pick the right ramping system to get people in and out, up and down and around. The module, so that's usually based on like the directionality of traffic. Sometimes you have a one-way type aisle system, maybe two-way. And the module is basically trying to set the width of your bays, right? And then your turning bays. So if you can get people in and out, around, up and down, into their spots, and you can do that efficiently, you'll have a good function, and then your form will follow that almost right off the bat. So we're finding that the most beneficial way to do that is by minimizing the obstructions in the floor plate. So that's columns, shear walls, anything that protrudes that would keep somebody from looking across the floor or getting from one place to the other. And the ramp can be one of those things, right? You can't walk through a ramp to get to a stair tower. So we really got to think about how everything lays out and how we're going to do that in the most efficient way. If I didn't say it, maximizing spans is another one, because that will limit the number of columns that you need, and repetition. And it's every time we can create the same thing over and over and over again to build, we create an efficiency in that structure, and we create a better function in my mind. So again, I've said before that in our market, PT is winning out because it gives the versatility, the flexibility, and accommodations that provide that better function. And to be fully honest, like, because we're kind of predisposed to that in our market, a lot of times we have to kind of take a step back because PT works so well. We have to kind of, as a value to our clients, we have to say, all right, maybe we should evaluate another system just to make sure that maybe there isn't something we're missing. So we do evaluate on a lot of projects. We'll look at a garage multiple ways. We'll look at PT, precast, maybe steel, maybe piled, but we'll do that in the interest of trying to figure out the best solution. And time after time, we're finding that PT is winning because of all the flexibility, especially if you've got some odd condition where you've got a weird shape, or you're especially going underground, or you're looking at vertical expansions. It just works better, and it saves the owner costs. We actually have a couple projects where we were asked to look at it. It's always two ways, right? Precast and post-tension. And in multiple scenarios, in this market, people think, well, we can get precast cheaper. And we found that after we did an objective analysis, we found that in several times post-tension won out from a cost standpoint. So it kind of like changed people's expectations about what's feasible and what's efficient.
Yeah, this may be kind of reiterating some of what David just said, but we, from the construction side, obviously we have a vested interest in one over any of the other options. But we do a lot of work with engineers or owners as they're kind of in that DD phase. And, to David's point, one of the things that we find is, people may start, and I know we'll talk about this later, people may start looking at the money aspect of it, but once they kind of commit and get into it, the flexibility and the of a cast in place post tension deck, whether it's standalone or whether it's something that has something coming off the top, just really seem to win out. Especially if there's, they need that space, a certain spacing of columns for the parking, but then they're going to build something over the top of it. The flexibility to do that with a cast in place PT structure really seems to be attractive with the people that we work with. So I would agree. We see a lot of people who, especially those who are going to be investing in the deck long term. You're going to own it long term. Schools, like universities, airports, people like that they need a quality product that's going to serve, not just from a functionality standpoint, but serve them well for a number of different reasons. Interestingly enough, as you were talking, David, one of the things that I think comes up a lot that is secondary from a construction standpoint is the safety aspect of a finished deck. And I know Asit and I have talked about this with different options, but just the lighting aspect. I'm family man and have two daughters, and as one's going off to college and as she's in a parking deck, being able to see a lot easier. Cast in place post tension decks seem to be brighter, and there's lots of flexibility to make it even brighter, as Asit can maybe speak to with some of the designs that we see in Texas. But I think as we work with owners and developers and other engineers that maybe aren't as sophisticated as you guys on this call, those are the things that we run across. Is they initially start with money, but the functionality and the flexibility win out overall, because as we're finding, we could be more and more competitive as we start working with them on their true needs, and we aren't confined by member sizes, let's just say.
My experience is with a lot of multifamily projects, although we do a lot of standalone projects as well. But one of the things that comes to mind is floor-to-floor heights, clearance, because when you're limited to a floor height, then post-tensioning flat plates is the way to go, right? Because you can have a flat plate system. Maybe it might add some more columns, but then you can go to a double cantilever system where you have members about 13 to 14 inches max for the floor plate, and that allows you to reduce the floor-to-floor height and gives you a much open look, a much better lighting in the garage, and it's very popular and definitely in Texas for sure. And in general, flat plates I think are the most efficient way to do parking garages. Talking about functionality, for whatever reasons, especially on multifamily projects, we have been asked to put pool decks on the roof level of a 6-story parking structure. And we've actually done quite a few of those. And I mean, post-tensioning is probably the only option in those circumstances where you have to span 60 feet and go across several bays and be able to do kind of weird things that the architect wants. And we've successfully done some of the projects. One project that comes to mind is in Charleston, South Carolina, overlooking the ocean. the developer wanted this very high-end pool structure, and it worked out really well. So the ability for you to be able to use bend tendons and move things around to achieve the load paths and the load transfers, you can do it very efficiently with post-tensioning.
Yeah, I think jumping off what Asit just said about the floor-to-floor heights, something to keep in mind that we've run into quite a bit, at least on the East Coast, is in both Washington, D.C. and say Charleston, South Carolina, where jurisdictions have building floor height or building height limitations. Post-tension, cast-in-place parking garages really come into play when you have that flat, either that flat plate system that you can reduce your floor-to-floor. Another thing with the floor to floor is there's a big cost in the facade of the building. And if you're part of a multifamily or you're underneath a taller building where facade cost is expensive, reducing that floor to floor is really important. I also work on quite a few standalone cast in place post tension structures, parking structures, and the long span structure works very well. We typically have bays in the 27 to 30 foot range, depending on the parking widths, along with like a 60 to 62 foot span. And having those types of structures, we can go up to 10 plus stories without shear walls, which is really helpful. That speeds up the construction. That also limits the cost and creates some openness in the deck, which is helpful for security. So there's a lot of benefits of post-tensioning that can be brought into all types of structures, whether it's a standalone parking deck or if it's a parking structure that's underneath or adjacent to another building.
Yeah, and I would add, Tom made me think of this, that we've all ridden in parking decks that feel like some type of carnival ride, but that is one thing about a cast in place PT deck is that to Tom's point, they're open so you can see. So even as a driver who's trying to navigate a parking deck, you've got the space to see for safety purposes. You can slope those decks. This is the construction side, pretty easily to get water where it needs to be. But it also gives you a nice smooth ride. You're going through it's very solid, and you don't get that bounce effect as the car drives by and you're walking to your destination. So I know that's an advantage that the openness and just general cast in place PT provides.
Right. And to that point, Mike, I mean, that's definitely, you start talking about, we built upon the conversation about the functional design and then the safety aspect and really the user comfort factor. This is that whole other discussion point of user comfort, not only as a pedestrian, but as a driver, and the safety part, it all ties in. Maybe some thoughts and discussions about the stair elevator cores. I mean, this is another thing that people kind of sometimes, have a fear of, I'm heading to this stair elevator core and it's leading me down to the ground or wherever I'm trying to go, to a ped bridge or whatever. But it's at these corners that some people feel like, oh, if I'm in a typical garage with this core and with the stair in a box and things like that, it's a little scary. What are some of the cool things about too with the cast in place PT framing and cast in place framing in general that really helps open up these stair elevator cores? Any thoughts on that from anybody?
Yeah, I think from the openness of the stair and elevator cord, one positive with the post-tension cast in place structure is that you can use just columns and beams or columns and a flat plate, create the openings. And then if you want to create an open vestibules for the elevators, or you want to have glass around the elevators, or you want to have an open stair, that's really easy. And we don't require walls around those. So for security purposes, being able to even just identify where the stairs are. A lot of times, in certain decks, you'll see just walls around these boxes in the corners, but you may not be 100% sure if it's a stair. It could be electrical room or something else like that. And this just, you can see that a lot easier. Actually putting where the stair and elevator cores are, there's a lot more flexibility of where you can actually place those. So obviously you have to stay out of the ramps and the drive aisles and things like that, but you have a lot more flexibility where you can put them. And then, as I mentioned earlier, especially if you have a long span moment frame system, You don't actually require shear walls, so we're not using those for the lateral system. So there's a lot of benefits and a lot of flexibility that a cast in place post-tension structure provides.
To add to what Tom just said, you can have a vent shaft opening. You can have the elevator shaft opening or a trash chute opening, and a lot of flexibility in placing it wherever, and you can frame beams around it. And post-tensioning just gives you the option to do it in an efficient manner. Sometimes without beams, just flat plate, or sometimes with beams, but it gives you a lot of efficiency and flexibility in framing around penetrations in the garage. So
a little bit about what you mentioned with openness and coupling it with your destinations is something a lot of people don't think about is signage in a garage and how to get from one place to the other. So we're always trying to advertise, where's your destination? Is it to a stair tower? Is it to an elevator core? Is it to a ped bridge? And if you can have a flat plate, it's great because you can hang your signs off and they're visible all over the floor. If you've got a beam system, your beams are typically spaced far enough apart that when you place your signage at the lower part of the beam at eye level, you can see 60 feet down and still see that sign as you're driving. So you have visual cues as you're navigating the garage to figure out where you might go. Whereas in like other systems that may have stems at 4 feet on center or 6 feet on center, it's kind of hard to see those signs. And if you're trying to minimize headroom heights, you can't put signs down below those members because you'll be hitting them with your cars. So that's one thing. The other thing, back to the lighting, is in order to have good photometrics, you got to have those lights spread out, right? In a post-tension structure with regular beam spacing or a flat plate, you can mount those lights right to the surface of the soffit of the slab and get great distribution because your light source is further away from the pavement, so it spreads out further. In other structures, again, where you have to maybe put them in between other members that are tighter, you've got to trunnion mount those. So it's an added cost for that. And now your fixture's close to the floor, so you get a less favorable photometric. So again, with the floor-to-floor heights and the openness of a post-tension structure, you get some of those advantages of some cost savings for your lighting and a better end product.
And I don't want to speak outside my realm of knowledge, but I think, David, to your point, and you guys may be able to speak to this more, but we see that for sprinklers and drainage pipes and whatever, that the ability to run those up tighter to the ceiling so that they're not hanging down below, beams and things like that. That's always been an advantage that is pretty attractive to, the final appearance of a deck. So I don't know if there's other, I'm not an expert on fire resistance and fireproofing, but maybe you guys could speak to that. But I know being able to keep those sprinklers up a little higher and out of the way has always been an advantage.
And talking about openness, we cannot forget about barrier cables, right? The barrier cable system actually gives you a lot of, it allows you to really give a lot more openness, whether it's an interior ramp or on the exterior. So, and probably a lot easier to install too, right? Compared to other framing systems. So I think barrier cables really are a lot easier to install in a parking garage. Michael, you want to add something to that?
Yeah, for sure. We see that a lot. I mean, we were talking about lighting before. So if you've got cables versus a wall, you definitely get a more open feel. One of the advantages we're seeing now, I think David or it may have been Tom mentioned earlier, that talking about a facade, there have been decks where we've poured crash walls around the edge and been able to pour it in a manner that, there was no facade needed because we're able to provide pretty nice looking building. You've got the slab, maybe you've got a perimeter beam, maybe you don't, but we're able to give a pretty nice exterior appearance as cast instead of the extra cost of needing, something to cover up, the structural system that is less attractive. Now, again, there's going to be times where somebody needs a look to match the buildings of a downtown setting or something like that you can't avoid. But in some of these standalone decks, we've been able to provide a pretty nice looking building Some with buried cables, some with not buried cables. From the outside, it saves some money on the facade. But definitely to your point, a seat, I mean, buried cables are definitely easy. They're very easy to install on the outside. And if you do it right, they look pretty nice, and provide that openness that you a lot of times are looking for.
Another point, all of you, that comes to mind is mixed use applications. We have done several garages where you have apartment units right next to a parking garage, and the topic of vibrations comes in the picture, right? Owners will come in and say, hey, what can we do so that we can control or mitigate the vibration in the unit adjacent to this apartment? And I think cast in place, we've done some vibration analyses to, to ensure that you don't create an issue for the folks who have a unit right next to a turn lane or where people are parking. And I think post-tensioning allows you to adjust your concrete design because it's a cast-in-place member to allows you to essentially address that issue. So there are other systems where it'll be way more bouncy. So that's a very important advantage of using post-tensioning in those applications. And mixed use applications are just increasing every single day. I mean, that's just you're living in high density areas, and those kind of situations keep arising all the time.
I'd add to that to say we are seeing a lot more of those because to David's point before, a lot of times people don't like the look of they think they don't like the look of a cast in place standalone deck in a downtown setting where they need a lot of parking. So they'll put storefront, and the flexibility of a cast in place PT deck, you can do that and still have parking above it. And we're seeing that more and more. So you can adjust spans, you can adjust floor to floor heights, kind of, to borrow a term, a la carte, approach to just a little bit of a mix change on a parking deck. So.
A specific example of that is we had a project recently in a downtown area, urban environment, very tight constraints. It was a 90-foot wide site. They needed X number of cars because they were replacing a surface lot for a housing complex with a hotel, and the hotel needed parking too. So the garage had to serve the function of the hotel and to make up for the spaces lost for the existing residents. And there was going to be a story below grade. It had to hit the level of the hotel at 2 at a certain height. It had half a level of retail at grade. And then it had 6 stories of future residential on top of it. And we were trying to figure out, how do we get the space count? Because we only had X number of levels to go up in it, and there was a street next to it. So we were landlocked on 3 sides, and there was a kind of alleyway. We said, hey, let's build the parking over the roadway. So we cantilevered the garage out 18 feet over the roadway once we got up above fire truck height. And every level we cantilevered out. And in looking at that, the edge of that, the perimeter of that structure had brick on it. Right, so we had a very sensitive finish that was heavy, that was cantilever at the end of an 18-foot cantilever. And this was during conceptual design, and we're like, well, what kind of systems can we use? PT was the only thing that worked, because with the headroom heights, we were not going to be able to get another system to be able to stack and meet headroom heights and be able to park under where we needed to get out. And so that was a perfect example of where we were able to meet the not only the structural requirements, but the serviceability requirements. We couldn't have the tip of that member jumping up and down every time somebody drove on it. And we had a very robust PT system that worked for that. Plus, we were able to accommodate, detail that for in the future, whenever they decided to put 6 additional levels of residential on top of this thing. So it just turned out to be a great solution for that particular project.
The ramping flexibility and also warping and drainage. And I think that's really important with a cast in place post-tension structure. From the ramping side, you have a lot of flexibility with the slopes of your ramps, whether you have blends at the top and bottom, whether it's a speed ramp, whether it's a warp type ramp. you can accommodate all those things with a cast in place post-tension structure. And then in addition to that, on the drainage side, again, you have a lot of flexibility with where the drains are, how you drain from high to low. And that's just something that this system provides, that flexibility. I mean, I think Michael can probably jump in on that, but it's just, you have adjustments that you can make with the formwork that can add to the flexibility of that. So I think that's really important. There's a lot of things with the ramps that come into play on different projects where you're entering from a street or an area, or you may have entering the deck from two different elevations. It just gives you a lot of flexibility with that, and you're not tied down to something very specific.
As a construction guy, we'd rather see a straight ramp with no warps. I'm teasing, but you're right. I mean, 100%. I mean, we get asked to do things all the time, and you can do it. There may be certain parameters you have to kind of work around, but they're pretty limited. I mean, it's pretty amazing whether it's the company I work for or companies that I've worked with in the past. It's kind of the only limitation is your imagination with cast in place post tensioning, and we've seen helical ramps, speed ramps, warped ramps. So yeah, you can get pretty creative, and there's a system out there to help build that. It may take a little time, depending on how creative you get, but for the most part, I mean, when you're comparing it to other systems, you're gonna get what you want in a pretty reasonable time frame for a cost. I mean, the cost of doing that in a cast in place has got to be significantly less, because it may not even be possible with other systems.
Something else I wanted to kind of touch on before we kind of bring our discussion to a conclusion, and it's back to the whole topic of floor-to-floor heights, and then the issue of underground parking garages, the underground parking element. When you get into excavations, and again, buildings that have parking underneath and they go underground, there's sometimes these misconceptions about, well, how do I do that? What's the best system? I can't use post-tensioning because I can't stress it, or something like that comes to mind. And so there's a bunch of mixed signals out there in the industry, I think. So I guess I'd like people to maybe talk a little bit about not only can you do post-tension structure below ground, and it does have the major advantage of helping reduce that excavation cost, but just some of the logistics of turning the PT parking below grade versus what some people think about it.
Yeah, the one topic we need to talk about is underground parking structures. And from time to time, all of us are in a situation where we have to have a parking structure, I don't know, 2 levels, 3 levels, 4 levels in the ground. And you scratch your head thinking, okay, what's the best way to be able to accomplish that? And in my experience, post-tensioning has worked every single time, and not only from achieving floor-to-floor height efficiencies, which will reduce the cost of excavating, overall for the project. It really allows you the flexibility to maintain the column structure throughout the upper floors and still be able to achieve a very efficient parking option. So I think post-tensioning has for us worked out to be the most efficient solution in those cases. And issues like how are you going to stress the tendons? They always come up. But there are many ways to accomplish that, by putting pour strips around the perimeter or have internal pour strips. That has you can always come up with solutions to handle stressing.
I think there's a misconception that just because you have a garage below grade, it's somehow fully protected kind of thing. I mean, there's still moisture in the air. It's still exposed to the de-icing chemicals that get dragged in. It's tempered maybe, but it's still an exterior type of building in standalone structures. I've done several below grade plaza type garages, and from a functional standpoint, we still want that long span construction, right? You still want those nice open views. You want to still be able to navigate the floor and see where you're going. It's not a problem. And when you're talking about plaza systems, those loads get heavy. I mean, you're 300, 400, 600 pounds a square foot, and a PT slab and beam system can handle that easily, right? So, and it's durable. They can waterproof it. It's robust, and they can do all kinds of different things on that plaza that maybe you can't do with other systems. So we find it's not been an issue at all to do it. And like you said, pour strips and, you know, a little bit of sequencing can do a lot to get it to work out fairly simply.
I think I'd add, I mean, we've built in the last year and a half, I think we've built 3 across our company that were below grade, or at least a couple of levels below grade, and all cast in place, post tension, and, you know, stressing is there's options, to y'all's point. And I live close to one of them that's now open, and you know, the below grade part, you know, you start to value light, and where you're headed, and, you know, having that system where it's pretty open underneath, and having that extra light does make it a lot more easy to move around. So, and I'll say, you know, just from the below grade part, I mean, being able to build those with your dirt work is what we call it, but excavation and anything to do with digging that out, that's expensive. So if the more you can reduce that, especially below grade, especially if it's in a downtown setting or a city setting, the more you can reduce that with by reducing floor to floor heights and, you know, having flexibility with what the structure looks like, the better off you're going to be from a construction cost and just, you know, functionality.
With low grade construction and PT construction, you know, your frames are resilient enough to be able to handle unbalanced load. So you might not be stuck with a cantilevered retaining wall with a massive footing under it. You know, basement walls are an option because you have enough frame system to be able to handle that. Where, you know, other systems you probably don't. You're probably gonna have to work on a shear wall path, load path, or something else to get that to just handle those kind of loads.
So yeah, we did talk about a lot of the mixed use discussions, and as far as that's concerned too, you talked about, you know, mixed use where there's something above you, there's plaza, there's apartments, there's a hotel, there's an office building, whatever else, but also, you know, obviously in parking structures of a mixed use nature, they have a lot of cases where there's retail, restaurant, office space, or whatever it might be actually in the levels below parking. And so one of the things I know I encountered in my career, there's a lot of owners that want to make sure and have that space function correctly. You got to have parking above. And this touches on several things. It touches on the separation of the occupancies. It touches on the waterproofing side of things, touches on vibration, all those different elements. You don't want to have a problem with those occupied spaces underneath parking. So maybe just a brief conversation amongst the 4 of you, and I'll let maybe Tom lead off about talking about how much more capable from a functional standpoint it is to separate those occupancies from parking using cast in place PT structure.
From a mixed use perspective, where you do have, say, a retail under parking, that happens quite often. It's cast in place post tension structures, very, very good and flexible and functional with that system. A lot of times you'll want maybe a waterproofed membrane with a sandwich slab above, and we can easily accommodate that with a post tension cast in place structure. It may need to be just slightly thicker, you know, slightly deeper to accommodate the extra load, but the whole system can be very similar. It can follow the same grids as you would have above, so there's not much change in the formwork or anything like that. You can also achieve, it's very easy to achieve a taller floor to floor in those retail spaces or any other, you know, hotel lobbies or multifamily lobbies, things like that. And then you can also, going back again to the ramps, there's just a lot of options with the ramps to get above those spaces much faster than you would in other types of systems. So a lot of flexibility, a lot of capacity, yet you're not straying too much from the typical. So once you get over that first level, you're going back to a typical parking level, and it keeps the cost keeps the cost down.
Flexibility is there. You don't have to rely on a defined member size to give you that flexibility of what you build, where you build it, how you build it. So the product is a lot easier for things like mixed use or below ground or any of that.
I think on mixed use projects where you have owners wanting to have store space where they don't want any columns within in their retail area, so they want columns that are spaced further apart in both directions. If the post-tensioning allows you to, even if it's for a portion of the structure, to make those adjustments in the framing to accommodate the longer spans and in an efficient manner, which would be very hard to do with other framing systems.
The slabs also provide an opportunity to embed conduits if desired, right? So I know a lot of owners don't want to see that if they've got a nice open feel, and it just gives them an opportunity to hide some of that.
One other thing too, we really didn't talk about, but in these mixed use type projects, if you have to transfer columns or anything like that, a post tension structure, I mean, it's key, and that's key to giving the flexibility on the first floor or the first couple floors, making that transfer very easy to do with post tension structure, and that's probably the first type of system you go to in these cast in place parking garages or any other type of building.
All right, so that's been great discussion. Appreciate everyone's input and expertise and thoughts on all these different functional advantages and benefits, and really getting into the detail of how things interrelate from a functional standpoint, and how the post-tension framing and PT parking structures can really lend themselves in an excellent way to make parking as functionally efficient as possible, and all these other different elements we talked about, safety and efficiencies and mixed use and a variety of other factors. So appreciate all of your input in this panel discussion, this first episode. And again, as we forge ahead with our other episodes, we're going to be talking about all the other benefits and topics related to PT parking structures. So again, thanks for your contributions today in this panel discussion, and we'll see everybody else next time in our other episodes related to, again, all the major advantages of post-tension parking structures. Thank you.
Thank you for joining us today. Be sure to visit our website at www.post-tensioning.org for more information and resources. Stay connected by following us on our social media channels to keep up with the latest updates and upcoming episodes. We look forward to seeing you next time.